Hello everyone, this is Mr. Cunningham, and today we're going to be going into our last section in naming and writing formulas. And today we're going to be talking about how we name and write the formulas for acids. But a little background knowledge on acids. Many of you probably have varying experience with acids. The movies usually portray them as substances that will, react and eat through other materials, which usually that's in the movies they usually make that dramatic, much more dramatic effect than actually happens. But acids will eat away at some materials. Some acids that you might be familiar with are, one of them is hydrochloric acid, which is usually the one that we use the most in chemistry, in high school chemistry. Also, you might be familiar with something called acetic acid. And acetic acid is actually an acid that's in vinegar, and vinegar contains 5% acetic acid. Also, another one you might be familiar with is something called sulfuric acid. Sulfuric acid is used a lot in batteries, and they use it to make pharmaceutical drugs, and it's used in a lot of chemical applications. Also, something called citric acid. Citric acid is in citrus fruits and oranges and other tropical fruits. So those might be some acids that you've heard of, but let's get into kind of how we name and write the formulas for some of these acids. So let's look at how we can name and write the formulas for acids. And we're going to be naming and writing formulas for acids all year, and we'll be using acids in labs all year. So let's make sure that we can get this right. So the first thing we need to do when naming or writing the formula for an acid is we need to identify that it is an acid. We've been talking about a lot of different compounds and how to name them. So we can really make this easy because acids will have an H in the front, or hydrogen in the front. So all that it means when it says has HX in front, that X stands for a subscript. So a 1 or a 2 or a 3 or any number, but it will always have hydrogen in the front if it's an acid. So that's what we need to look at first. If it has hydrogen in the front, we're going to name it as an acid. The second thing we need to do is look at the anion ending. So let's look at how there's actually 3 ways we can name them. So let's look at those. So when the anion ends in IDE, ATE, or ITE, we're going to name these acids in different ways. So when the acid ends in, the anion that's involved with that acid ends in IDE, then we're going to name it as hydro with a stem, and then add an ic, and then acid. So an example that we've already talked about in this video would be hydrochloric acid. In hydrochloric acid, the formula is HCl. So the anion is chloride. So chloride ends in IDE, so we name it hydrochloric acid. The other two are ATE and ITE, and those will involve polyatomic ions. For instance, nitrate ends in ATE, so an acid that involves nitrate we would call nitric acid, and an acid that involves another polyatomic ion that ends in ITE, we would write the stem and then OUS with an acid at the end. So an example of that would be something like chlorite. So we would call it chlorous acid. But let's look at some other examples of those. So here we have HF. So it starts with H, so we can automatically conclude that we're going to name this as an acid. Then we look at the anion. So this anion is fluoride. So this is an Fl minus, so this is fluoride. So we name this using the IDE naming system. So when we name this, we have the hydro with the stem, we add the ic, and then we add acid at the end. So this would be called hydrofluoric acid. Okay? So let's look at another one. So here we have HNO3. So we have the H, so that means we're going to name this as an acid. Then, remember we did polyatomic ions last week. And NO3 is a polyatomic ion. And that polyatomic ion is called nitrate. So because this ends in ATE, we're going to name this acid a little bit differently. So when we name this acid, we have the stem of the polyatomic ion, add an ic, and then acid. So this is called nitric acid. Okay, so let's look at one more, one that would end with the ITE ending. So here we have HNO2. Now, has an H in front, so we're going to name it as an acid. And now, this looks very similar to the last one. It looks very similar to the nitric acid, but this one has one less oxygen. So we would name this nitrite. So we're going to name this acid a little bit differently. So because nitrite ends in ITE, we name it with the stem, and instead of the IC or the ic, we're going to name it with an OUS. So this would actually be called nitrous acid. So in review, first thing we have to do is we have to look at the compound and does it start with H? If it does start with H, or if it starts with hydrogen, we're going to name this as an acid. And the second thing we need to do is we need to look at the anion. And depending on what the anion ends with is how we're going to name it. So if it ends with IDE, it'll follow the hydro, then with the stemic, and then acid. Okay? If it ends in ATE or ITE, we're going to name it a little bit differently. And so if you need to, you can go back and review the IDE, ATE, and ITE anion endings and how we name those and look at those examples. But otherwise, just remember we need to first identify, is it an acid? If it is, then we'll look at the anion ending. So something that we also need to know how to do is we need to kind of know how to go backwards. So if we're given the name of the acid, we need to know how to find the formula. And really that's pretty simple. We just work backwards. So if the acid has a hydro and it ends in ic, then that means the anion has an IDE ending. And the stem, or what's in the middle for that acid, is going to give you the name of the element that's involved. And then if the acid ends in just IC, then that's going to tell us that the anion ends in 8, so we can kind of work backwards to find that. Also, same thing for ITE endings. If the acid ends in OUS, then that means the anion has an ITE ending, and we can kind of work backwards. But we'll look at how we can figure those out more in class, and we'll review and look at that. So that's going to really end our video lecture for today. Please make sure if you have any questions that you write them down so we can talk about them in class. So thank you for watching the video, and come to class prepared so that we can clear up any misconceptions on how we name and write these acids.